Welcome back, everyone. We're going to talk about blockchain now, which I'm sure you've all heard of, probably in the concept or in the context of Bitcoin or in the context of a distributed ledger. Um, and for today's purpose, we're actually going to look at blockchain in general, right? So it's actually more general than either Bitcoin or distributed ledger. Blockchain is ordered distributed data storage verified by cryptography. So when you hear something's very general like this and it's got a lot of buzz around it, you might think, should we use it for my project? And to answer this question, we've tossed together this handy flow chart. Should we use blockchain for this? No. But what if? No. A little bit tongue in cheek, but I really do mean it. Unless you're building a cryptocurrency, there are almost always simpler approaches to the problem. Um, Very rarely do you actually need a distributed data storage solution that's verified by cryptography. But if you do, I guess let's dive in. So a blockchain is made up of blocks, right? Each block contains a little bit of data, right? A timestamp and a hash. So this data block there could be anything, right? So this is your transactions, ledger of transactions in Bitcoin. The hash is the most interesting part here. This is calculated based on the other data in the block. And as you'll see on the next slide, this is really kind of the core of the problem and what makes Bitcoin and blockchain work. So as the name suggests, blockchain is a chain of blocks. And what ties this chain together is the hashes. So the next block in the chain always has as part of its data the hash of the previous block, right? So if we look at the second block in the chain here, it has the hash of the first block in the chain. So when we calculate the hash of each chain or each block in the chain, part of the data that we're using to compute that hash is the hash of the previous block. And this is what makes it cryptographically secure, because the blockchain can't be tampered with. There's no way, if we were to remove a block or try and add a block in the chain or tamper with the data in the chain, that would change the hashes in the chain, and we wouldn't get this correspondence between the hash of one block being included in the next block. The hashes wouldn't line up, and everyone would know that the chain was not valid. So blocks are added to the chain by a process called mining, right? And mining is really just finding a hash with certain properties. So a bunch of different people are competing to get a block in the chain, and this competition, this mining that they're doing to get a block in the chain, is just calculating hashes. And so a hash function has very specific properties that we're not going to get into too much here. But the thing to know about a hash is if you change the data a little bit, the hash changes a lot. And given the same inputs, the hash is a true function, so it always produces the same outputs. So given a timestamp, a previous hash, and data, if I run the hash computation, I'll always end up with the same thing. So if we want to calculate a hash with certain properties, you have to add something else in there, and we call this something else a nonce. So this is basically just a number that we include in our blocks data that we increment each time. And every time we increment this, because of the properties of a hash, we get a completely different hash. And we call a block mined when the hash starts with a predefined number of zeros. So if you can imagine all these different actors trying to compete to add a block to the chain, they're all mining, trying to find the right nonce that gives you a hash with this special property that starts with a whole bunch of zeros. In the case of Bitcoin, this predefined number of zeros changes over time. So the goal is to keep mining time to around 10 minutes, right? They find that this leads to, fast transactions and kind of a stable system. And so every so often, I think it's every 2,000 or so blocks, they have to adjust how many zeros do you need at the start of that hash. So that's blockchain in a nutshell. So next, we've got a coding exercise for you, and I hope you all enjoy it.